Hello, Calculus BC students, and let's discuss this first practice exam. Uh, Question 1 here. You're given a table of values for W, where W are the number of workers in an office building um, in T minutes, where T equals 0 is 8 a.m., so T equals 60 is 9 a.m. And you're given dy dt, which since Y is W of T, that's also W prime, the first derivative of W, and W0 is 2. So it asks you two questions. Find W prime at 65 and W double prime at 65. And using correct units, interpret the meaning of that. So here we go. As I mentioned before, W prime is the given dy dt. That is the first derivative of W. Now be careful. They want the value at 65, but you want to plug in the y value, not the x. So from the table, W of 65 is 60. So you want to plug in 60 for y to find W prime of 65, and you get 8/5, all right, or 1.4. Then you want to find the second derivative. So you have to do the derivative of this, all right? And I kept the 1/15th out front, and then I did the product rule. Um, and remember, you're doing a derivative implicitly. So every time you take a derivative in terms of y, you multiply by dy dt. And you get your u dv plus v du, all right? And then you plug in the values. Once again, plug in 60 for y, plug in 8/5 for dy dt, and simplify that, and you get -8 over 375. Okay, and remember, you will have access to a calculator on your AP exam, so you can do all that in the calculator if you wish. So the meaning of that, what does that mean? Well, remember, it's a second derivative. It's the rate of a rate of change. So the way I wrote it is that it's the rate at which the workers that enter the building is decreasing by this number, and it's workers per minute, or workers per minute squared, when t equals 65. Okay? Or you could say the rate of change of the rate at which workers enter the building is -8 over 375. Anything like that. All right, so the person who wrote this assigned 5 points to it. 1 point for W prime of 65, 2 points for the derivative in terms of T, 1 point for plugging in or find the derivative at 60, second derivative at 65, and then 1 point for the meaning. All right, so a lot of work to do there. B, this was probably one of the challenging parts. Find this integral from 0 to infinity, so it's an improper integral. Okay, so first thing you need to do then is set it up as an improper integral. Replace the upper bound with b to limit as b approaches infinity. All right, and then we do the antiderivative. Don't forget to put the 1/3 out front. Antiderivative of w prime is w, and then you plug in b and you plug in 0. Now, this value you can get from the table. Okay, but what about this limit here? Limit as b approaches infinity of this value. Okay. How do I find the limit as b approaches infinity of w given the table? Okay, well, uh, it turns out that that limit is 100. Okay, and here's how you know it. This was the challenging part. Okay, go back to this. This is a logistic differential equation. That should look familiar, right? A constant times y times a constant minus y. That's a logistic differential equation. So this is going to have a horizontal asymptote and at m, and in this case you have to rewrite it because it's y over 100. You want to factor out the 1 over 100 and write it as, think of it as 100 minus y. So that is what tells you that this graph has the graph of w has a horizontal asymptote at y equals 100. So this limit right here is 100. Okay, and then you end up with 100 minus 10 is 90 times 1/3 is 30. All right, so that was 3 points. 1 point for simply just writing it as an improper integral with a limit, which you all should hopefully were able to do that, and then 1 point for evaluating this limit using the horizontal asymptote, and then 1 point for the answer. Okay, so even if you weren't sure what to do there, hopefully you at least knew how to write that as an improper integral. All right, let's look at part C. Part C says use the left Riemann sum to approximate this in 1 over 45 integral 0 to 45w. Explain what that means. Okay, that I hope was really easy. All right, we know how to do Riemann sums. That's just area of the rectangles. All right, so do left endpoints using the left endpoints from 0 to 45, multiply by 1 over 45 when you're done, and you get 59/9, which I believe is like 6 and 5/9. And what is that? That hopefully recognizes the average value of a function. Excuse me. So it's the average number of workers in the building from 0 to 45. Make sure you say those, right? When your explanation, you must say from 0 to 45. Okay, so 3 points there. 1 point for doing a Riemann sum, 1 point for the correct answer, 1 point for the explanation. All right, moving on to part D. Use Euler's method with 2 steps to approximate the number of workers at 925. Okay, so Euler's method, another one. Hopefully that wasn't too bad. Just start with your point, plug it in the derivative, multiply by dx to get your delta y, and add it and get your second point. Do that twice, and you get about 90.48. Um, so 1 point for doing Euler's method with 2 steps, and 1 point for the correct answer. All right, part E, is there a time between 25 and 45 where the derivative of W is 1? Justify your answer. All right, when you see that, you should think of mean value theorem. Is there somewhere between 25 and 45 where the derivative is 1? And you can tell here that the slope between 25 and 45 is 1. So you had to show that. That was 1 point. To show the slope between 45 and 25 was 1. And then, since W is differentiable, then it's also continuous, and therefore we can use the mean value theorem to state that the W prime of C equals 1. All right. And notice, you don't even have to state by the mean value theorem. I mean, you can state that, but what's important is just saying the conditions. All right. Finally, for that, let P sub 2 of T be the second degree Taylor polynomial. It's centered at 65. Find the Taylor polynomial and use it to approximate the value at 85. Okay, so second degree Taylor polynomial. So I need the a P of 65, the P prime of 60, or W prime, W 65, excuse me, W prime of 65, and W double prime, excuse me, the second derivative at 65. All right, and both these values were from your previous answers, okay, from part A. So it's the formula, remember, it's the value at at 65, and then the first derivative times t minus 65, and the second derivative over 2 factorial times t minus 65 squared, okay? And you can simplify it if you want to get this, and then you plug in 85, and you get this value, which is about 87.733. So 2 points for your Taylor polynomial, and then 1 point for the approximation, okay? So I believe the whole first part they made worth, so I get 9, 12, 15. Okay, I'm not sure how many points it was worth, but I was adding wrong. Doesn't matter. I forget how they broke it down. I thought they said like 15 and 10 was their points, but okay. Let's go now to the second part, BC number 2. It gives you a graph there of function f, and then it defines g as the integral from 2 to x f of t dt. Okay, first question, find this limit, x approaches 2. All right, and when you see a limit like that, you can guess you're probably going to have to do L'Hopital's rule. Not always, but you can probably guess that. So remember, before you do L'Hopital's rule, you must show 2 things. You must show that the limit of the numerator and denominator both approach 0, okay? So take the limit as x approaches -2. You can try to plug -2 into here. You get g of -4, and then you get +8. Now, this one is a little extra work, right? What is g of -4? Well, now you have to go up to how g is defined. G is the integral from 2 to x of f of t dt. So g of -4 is integral from 2 to -4 of f of t dt. So you have to use the graph to evaluate that integral. All right. Now it's backwards, right? It's backwards 2 to -4. So I flipped it around. I made it -4 to 2 and did the opposite sign. So this integral ends up being 8, and then 8 minus 8 is 0. So the top is 0. The limit of the denominator is also 0. So we have to use L'Hopital's rule. All right. And then to do L'Hopital's rule, then I do the derivative of the numerator over the derivative of the denominator. Then I can plug in -2, and then I can get an answer. Okay. And notice when it says g prime of -4, right? This is the graph of g prime, right? Since g is integral of f, f is g prime. So you get the value for g prime from the graph. So 3 points there. 1 point for showing the limit of the numerator and denominator separately to show you need to use the L'Hopital's rule. 1 point for doing the derivative, in other words, doing L'Hopital's rule, and then 1 point for the answer of 4/3. All right, part B, find the absolute maximum of g on the interval -6 to 2. Justify your answer. So absolute maximum is our candidates test. I have to check the values of g at the critical points and the endpoints. So the endpoints are -6 and 2. The critical points is when the derivative is 0. Now notice the derivative is 0. This is the graph of the derivative right here. Okay, so there's 3 critical points. Okay, however, one of them is a local min. One of them is a local min. I only need to check the 2 local max, um, uh, which are let's see. I said 0 and -4. Well, actually, -4 is going to be a local min, but I checked it anywhere. Anyway, you could ignore -4 if you stated it was a local min. Um, But I checked anyways. I forgot that. I'm sorry. I forgot that they stopped at 2. So the critical point 2 is also the endpoint. So there's 2 critical points there, 0 and -4. All right. But since they only asked for the maximum, you can ignore. You don't have to do -4 in the candidates test as long as you state why you're ignoring it, that it's a local minimum. Okay. Or you can just do in the candidates test. So at any rate, here's your candidates test. You just plug in the 2 critical points and the 2 endpoints into the integral. And again, all of these are going backwards, right? So after you find the area, you switch the sign. And the largest value there is 2. So the maximum value is 2 and occurs when x equals 0. So that was 3 points. 1 point for considering the critical points, and then 2 points for the candidates test and your answer. All right, for part C, um, evaluate this integral. Excuse me, let me bring it back down. There we go. -3 to 1 x f prime of 2x dx. All right. This one, there's a lot to this one. This was another one that's quite challenging. Okay, let's start with this. All right, you have to use integration by parts. You might have thought substitution with a u and a du, but notice if u is 2x, or if 2x is just 2, right? There's no, you don't need the x out there. It's not part of your du. So substitution doesn't work. This is integration by parts. All right. So you want to make u be x. So when I do the du, the derivative, it goes away. And then when my dv is the f prime of 2x, the antiderivative of f prime of 2x is f of 2x times 1/2 to undo the chain rule. All right, so now I've got my, now write it in this form using my integration by parts. We're not here yet. uv minus integral v du. Okay, now I have this integral. Okay, now I need to do substitution because it's not just f of x, it's f of 2x. So I want to do u substitution. U is 2x, so my du is 2. So I need a 2, so I multiply by 1/2 out in front, and that's where that 1/4 comes from. 1/2 times that 1/2 is 1/4. And then I change these values from x values to u values. So now this integral becomes 1/4 integral -6 to 2 f of u du. Okay, and then here I'm just plugging 1 and -3 into the first part of my integration by parts formula. All right, this now you can get from the graph. Right, you're given the graph of f. So this integral you can get from the graph, and this area is 3. So again, just look at the graph. The area from -6 to 2, top minus bottom, is 3. And then the f of 2 and the f of -6, once again, you get those from the graph, plug everything in, and you end up with -15/2 minus 3/4, which is -33/4. All right, so 3 points there. 1 point for setting up the integration by parts correctly. Um, 1 point for evaluating this integral correctly using substitution. And then 1 point for the final answer. All right, the last 2 parts of number 2 here, hopefully those are pretty easy. D, the region R is the base of a solid. Use cross sections or squares. Writing integral expression to give the volume of the solid, right? Well, the volume is just area of the cross section, and integral, excuse me, of the area of the cross section. Since the cross sections are squared, then it's just going to be the integral of f of x squared from 2 to 5. Excuse me, there it is. Integral from f of x squared from 2 to 5. So that was just 1 point. Didn't have to solve it, just set it up. And then E, it gives you f prime of x is this. Find this sum, or so the series diverges. Okay, so I basically just, since a sub n is f prime of n, you just basically replace the x with n and plug it in there. So I want to find the sum of this geometric series right here. Okay. Now don't let the n minus 5 confuse you here, because notice it starts at 5. It starts at 5. So this is a geometric series. This is your r, because I'm multiplied by 1/2. Okay. Now to find the a, plug in 5 for n, right? Because you start at n equals 5. So 5 minus 5 is 0. 1/2 to the 0 is 1 times -4 is -4. So this is just a geometric series with the a of -4 and an r of 1/2. And then so just plug in the formula a over 1 minus r, and you get -8. So the sum of that series is -8. So that's 2 points. 1 point for recognize it's a geometric series, and then 1 point for the sum. Okay, so those are the answers to that practice exam. So I know that was hopefully pretty challenging, but all of those now you can see at least how to set those up. If you didn't make it all the way through all of them, hopefully you're at least able to set those up and see how we got those answers. All right, I will post another practice exam on Wednesday for you to work on.